Yeah, so we're recording. Really thankful to Matt Hein of Cedar Falls Utilities to present for us today. This presentation has been or at least a version of it has been given before at the Iowa Energy Conference. Some of the feedback that we got is that a lot of folks weren't able to attend. And so I got with Matt and he agreed to give this presentation another go. So a little bit about Matt. After completing his master's in mechanical engineering at South Dakota State University, Matt taught engineering courses and assisted in directing the South Dakota Wind Application Center. Matt then became a consulting engineer working with utilities throughout the Midwest to perform energy audits, retro commissioning, energy modeling, and strategic energy management. This led to his current position. Matt is now the Energy Services Manager at Cedar Falls Utilities, where he focuses on helping Cedar Falls residents and businesses use energy more effectively through energy efficiency and renewable energy efforts. Matt is a registered professional engineer in the state of Iowa. And with that, thank you for being here, Matt. I'm going to go ahead and turn it over to you.
Thanks, Jeff. I really appreciate it. And thank you, everyone, for joining the webinar today. So our title, Digital Gold Rush, the opportunity cryptocurrency presents for utilities. I have to start with a little bit of flash, right? So what if electric utilities could upgrade infrastructure without capital expenditure, increase revenue, lower rates, use more renewable energy, and add high-tech jobs to their communities? So as Jeff said, my name is Matt Hein from CFU Energy Services, and we're going to see if maybe there's some opportunities to do just those things. Within Energy Services, just a brief overview, we do demand side management. So on the customer side of the meter, looking at energy efficiency, electrification, all sorts of various things. But this program that I want to focus on today is demand response and how we look at that. Broadening out a little bit, how do we look at programs in general at CFU? Well, fundamentally, we start with the physics of something. What is possible with an energy efficiency or a demand response program? And then we look at the economics of it, because it doesn't matter if you could do it. If you can't afford to do it, then you're kind of stuck. And then after that, we say, well, human behavior. Okay, we can do it and we can afford to do it, but does anyone want to do it is the other side of it. Another way I like to frame that is what's possible, what's practical, and then what's actually actionable. So with that, talking about demand response programs, I want to zoom out a little bit to a cartoon that I've put together representing roughly what the Iowa utility grid looks like, so MISO in our case. So this is not an exact representation of any point in time. It's overly simplified, but I think it gets at what is going on in the wide grid as a whole. So we have our load in blue, starts low in the morning and then rises to a peak in the middle of the day, and then decreases as we go into the evening. And then we have wind energy in Iowa. So that's our green line, really high. The wind tends to be up at night, and then it does tend to go down in that mid-morning and then rise throughout the day and be high at night. And then we've got the checkered green area that's representing wind curtailment, because we have to match the production with the load on the system. And then the gray in the middle is going to represent our need for fossil fuel peaker plants. So there's not enough wind to meet the loads. We need to fill in that difference with fossil fuel peaking. Now, some people have suggested that all we need to do is spend a few $1 million on batteries, and that will solve the problem. So in this case, what if we spend about $7 million and get ourselves a 4 megawatt battery that'll last for 4 hours? So we can see on red the influence of having a battery on the system, where we're not curtailing as much wind because we can go ahead and charge the battery instead of curtailing the wind. But then we can also reduce the amount of fossil fuel use during that peaking time by discharging the battery. And then when wind is in excess again, we can pick it up and curtail. Now this diagram is a little bit off because it wouldn't repeat day after day, because on the left side where we charge the battery in the morning, that wouldn't happen on the next day because the battery's already charged in this scenario and ready for the next day. So to change that illustration a little bit. Now, what could we do as an alternative? One thing we could look at is a fast-acting flexible load, so a demand resource, demand response resource. In this case, hypothetically, let's say we have 20 megawatts of curtailable load on our system. So now we're increasing the amount of load from what it was before and using up a lot more of that wind energy, so we have to curtail less. But we haven't affected the fossil fuel use at all. We're curtailing that high load to prevent the peak from going up, but we still have that fossil fuel peaking requirement. But the thing to focus on is the fact that wind was cost effective before at that large amount of curtailment. And then we still have some pretty decent incentives for wind. So my suspicion is as load increases, wind production facilities will see an opportunity to put even more wind on the grid. And now that 20 megawatt curtailable load is there, and the amount that it's able to operate increases as the amount of wind has increased in proportion. And what's really interesting is what happens to that fossil fuel peaking in the middle. Because again, our load that we've been serving hasn't changed at all, except for that 20 megawatts of curtailable load. And the resulting fossil fuel peak has both decreased in its magnitude, so the height of it, and decreased in its duration, so how wide it is. It's literally squeezing fossil fuel use out of the grid by using this methodology. It's making it hard to run a fossil fuel peaking plant in a traditional fossil fuel peaking plant. So we might have to look at different options. And one of those options might be looking at some sort of blended mix where we have, say, a renewable hydrogen fast-acting peaking plant. I don't have it shown on this illustration, but conceptually, you could have that hydrogen using even more of that excess capacity of wind and reducing the amount of curtailment. So walking through a hypothetical scenario of what could happen to the utility grid if we had large demand response resources. So what might that large demand response resource be? Bitcoin miners. And the question is, well, who are Bitcoin miners? What are they? Where are they? When, why, and how, right? So I'll try and walk through each of those questions and answer them. So what is Bitcoin? Well, Bitcoin is a decentralized finite digital asset that's cryptographically secured on a blockchain ledger using pools of ASIC miners to do proof of work. I like to simplify that as Bitcoin equals digital gold, and I can walk through a little bit more why that is. Well, who are the miners? Well, the miners kind of have two terms associated with it. One is the physical computer hardware. That's that ASIC, so that's an application-specific integrated circuit. It's a big computer that does one thing, mine a Bitcoin. So that's the mining hardware. And then the mining companies, well, who are they? Well, they come in all shapes and sizes, but they generally have the same characteristics, that they're fast-moving, have a high risk tolerance, and access to lots of capital. Well, where are these Bitcoin mining companies? They're everywhere. And I have a strong suspicion that you have someone mining some sort of cryptocurrency on your system. It's fairly easy to get a computer or a portion of a computer and start mining some sort of cryptocurrency. There's thousands of them out there. A few of them are much more popular than others, but many people are running these systems all over the place. Where they prefer to run, though, is probably what we should focus on. They need large amounts of power, orders of magnitude, large amounts of power with low energy costs. It's their main cost associated with operation. When is this going to happen? Well, this is the digital gold rush title from the presentation. Now and as soon as possible. A couple of countries, China being the most prominent one, have banned Bitcoin mining. And so there is a tremendous amount of businesses and hardware that are trying to get plugged into utility grids to continue mining this digital gold. And so they want to connect as fast as possible. As an example, if you're talking to a Bitcoin mining company, they might say, well, I know you've never heard of us, but in 6 months, we'd like to have a 5 megawatt mining operation running on your system. That is a lot different than basically every other customer we've seen. You know, and what scale do they look to get to? Oh, 100 megawatts in 5 years is a pretty common statement from these companies. So just to give you an idea of the speed and scale that they talk about moving at. How is this even possible? Like, again, who are these people? How does this work? And why are they doing it? Well, depending on their business structure, oftentimes it's cash flow positive. So they are making money. It's highly scalable. One computer is about 3 kilowatts, and they just add another one to make 6 kilowatts and another one until they have thousands of these machines running on racks to get into the megawatt scale. And it's a very fast return on investment. Again, very high risk, but very good reward. So that's the why for miners. Why for utilities? Frankly, these are large loads with a relatively low cost to serve. They want to nestle in right next to substations, again, where they can get as much power as possible, as cheaply as possible. So those two factors mean that we're talking about increased revenue, reduced cost of service, potentially for all customers, because again, they want to use cheap electricity, so they're willing to curtail when electricity is expensive. That means that this is just simply the law of averages, where your cost to serve a customer is based on your wholesale rates. And if a large amount of your wholesale purchases are at a cheaper amount, the average cost is lower for everyone. And then it's possible to get infrastructure improvements at low to no cost up front. Again, just saying, hey, this is a risky venture, having you guys come in. We need you guys to cover the full cost of connecting you into the system. We're not doing a capital recovery type agreement. You guys pay for everything up front. They have access to capital, so that's typically not a problem at all. And then increased opportunity for renewables. That was kind of the graphics that I had showed earlier, what that scenario might look like. And then finally, community growth with high-tech talent. So roughly for every 3 megawatts of mining operation, they need one full-time employee with a salary of around $70,000 a year. So you can have an entire company of people servicing these machines. There are thousands of machines, so even at a really high reliability, we all know how often our personal computers or our work computers break. These are computers. They break, they need fixing, they need adjustments. So same type of thing. And then I toss this in because they are a potential heat source. So these mining rigs take in electricity, solve a math problem effectively, and produce a ton of heat. So they just chew up electricity and make heat. So there's a potential for recovering that heat and using it for different purposes. So those are the advantages, but I really want to highlight some of the risks because they are very real. So most of these operations are very modular, very fast moving, and they drop right onto the system. They typically don't build a building. So they are modular crates or containers. Some of them build right into shipping containers. So they're designed to get dropped off of a semi and they can get put back on a semi just as fast. So there is the potential that they disappear overnight, which means that any long-term contract has to be very carefully structured. They'll also take all the capacity that you're willing to give them. So thinking long and hard about future growth for the community and your capacity reserves on your system. If you're not careful with the agreements, you could lose money on the rates that you're willing to offer them. And then also because there's no physical building structure for many of these operations, their tax revenue is very low. So depending on what your community is looking for, those are things to consider. So some best practices, how to get the benefits and mitigate the risks. Locating near substations. That's usually where they want to go anyway, just to have access to that power. It also reduces the cost to serve. And it's not tying up, generally speaking, it's not tying up any land that could be used for something else in the community. Have 100% of the infrastructure costs paid by the customer. I would say capital recovery based on the ownership and rate considerations. So for us, we require 100% infrastructure costs paid by the customer, and then they own that infrastructure. We will operate and maintain it and charge them our rates for that, but we make it clear that they own it because it's just for them. We require a 2-month deposit before activation. So I talked about how you can go from 0 to 5 megawatts in 6 months. So the reason for a 2-month deposit is because they can grow so quickly. In our experience, it's very easy for a mining operation to double in size in 1 month. So if you say, well, we require a 1-month deposit in case you decide to leave, that would be okay if they were at steady state. So because they can double in size in a matter of weeks, you really need at least 2 months of deposit before activation. APPA has recently come out and talked about a surety bond as an alternative for that. So that's something that we're looking at for our future contracts, is to provide that as an alternative, simply because a 2-month deposit on a 50 or 100 megawatt system, well, that's a really big deposit that we would be asking a customer to make. So having some sort of bond in place instead is likely more practical at that scale. Also, making sure that you get access and rights to that demand response so that you can curtail these customers. This helps with zonal resource credits. So you have to have the capacity, but you get credited back because they're a demand response resource. You just want to make sure you're not impacting your capacity requirements and have that one-for-one exchange. They tend to be air-cooled or liquid-cooled. So air-cooled is louder, being aware of where they're located and any decibel ratings for the different development areas. Again, most of these companies are familiar with those types of requirements. Treat them like an industrial customer. They typically know what's going on. So sound dampening may or may not be required. Liquid-cooled designs are quieter, but then you might need some sort of spill containment to meet DNR requirements and other items. Make sure on the transmission side and just your operations folks are paying attention to the connection points and what's required. Most of this equipment is running at 415 volts versus a 480, 460 type thing. So those adjustments need to be made. Again, a lot of the 6 companies that we've talked to, they're all familiar with what needs to be done to make that happen. And just understand that they consider 5 megawatts to be a starter package to just test things out. So the scale of things can be quite a big deal. 50 megawatts and above, we've gathered they do tend to build buildings simply because the economics of building the more modular crates break down once they get to that scale. It's better to just have it under one roof. So really quick bullet points associated with Bitcoin miners. And at this point, I'd like to turn it over to any questions that you guys have about what I've discussed, or any conversations about miners you've encountered or various things that you've heard. I think you're on mute, Jeff.
Okay, everyone, you're welcome to unmute yourself and ask a question. I don't know if my chat is being messed up, but I didn't see any questions entered there. I'm going to get us rolling with some questions, Matt. First question I have is, have supply shortages, like when it comes to getting transformers, affected your ability to get these customers up and running?
Yes and no. That's a very interesting dynamic. We have found that we as the utility can have difficulty in getting transformers, but the Bitcoin mining companies can get them much faster. And having a couple of frank conversations, they said, well, we're willing to pay 3 times more than you are. And so we are getting prioritized in manufacturing. So when you say you go to the manufacturer and ask for a transformer, the reason they say no is because we already have them in reserve for our operation.
That's incredible. Yeah, just a note, I've heard the wait on some transformers is up to 2 years now, with some companies not even giving a timeline. So that's a good one.
Yeah.
I'm gonna go ahead and serve myself and sneak in. Actually, you know what? We've got some questions in the chat. I'm gonna ask one. Okay, we've got a lot of questions. First question is from Jason Willard. Sorry, Jason, if I'm saying your last name wrong. Jason's question is, are you making the Bitcoin miners meet the utility specs for transformers?
Yes. Yeah. What you'll find for the bigger Bitcoin mining operations is they often have former utility employees that you'll be interfacing with. So if you're comfortable speaking the language of transformers and interconnection, you're likely speaking to a counterpart that speaks that exact language. I'm a mechanical engineer, so I listen and nod politely, but really get lost after the first couple of minutes.
I'm a mechanical engineer too, Matt. I feel you there. Good deal. All right, next question is from Travis Waterman. Travis asks, how does this affect your system power factor?
We haven't looked at the system power factor as of yet, but it should be quite phenomenal because their power factor is 98, 99%. They just turn these things on and go.
Yeah, I'm thinking there should really be no inductive loads when it comes to essentially like a modular computer, right? There's no like electric motor that's like an AC motor.
Yeah.
Interesting. Okay. This question comes to us from Nicholas Lorenz. Nick asked, do you know the typical harmonic content for crypto miners?
Yeah, Nicholas, I'm going to tell you I'm not in electrical engineer. So if you're talking about electrical harmonics, I can't answer. If you're talking barbershop quartet, I still can't answer. So sorry. Our operations folks, in terms of connecting to these things, love them because they're, I mean, you plug in, turn them on, and they go. Their demand response, their ability to shed load, they can shed about 90% of their load without issues, and that can happen in a minute. So it's hard to beat from a demand response perspective.
Matt, what capacity in megawatts are we talking that can shed their load within a minute?
It's all linear. So conceptually, if you have a 10 megawatt mining operation on your system, they could shed 9 megawatts in a minute or two.
Wow, that's pretty interesting.
Now, your ability to signal them to initiate demand response, that's something we're still working on. We know one of the values that they represent is the ability to act quickly. Now we're trying to work through, frankly, the legality of how quickly we can signal them to respond.
Interesting. Okay, we've got another question from Greg Slanka. Greg asks, do miners typically prefer to accept utility source at primary voltage, for example, 15 kilovolts, and furnish their own transformers, or at a secondary voltage and use utility-owned / provided transformers?
The way we are treating it is we will serve crypto miners with our standard industrial rate for secondary voltage. They get what any other customer would get at that point. If they want a specialty contract rate, then they have to be at primary voltage. It also helps us, frankly, it helps us be more efficient in interacting with these customers. It basically says you got to be 1.5 megs for us to go into these more detailed conversations. Otherwise, find somewhere on the system and connect and do your thing, and that'll be fine. We've reached a point where we need them to be larger. Otherwise, the quantity of customers we would deal with would be just frankly too much. So we've set our requirement that they take primary voltage.
Gotcha. Here's another question, Matt. Do you know what type of coolant the liquid cooled units use?
It's a special miner rig fluid, but I'm pretty sure it's the exact same type of mineral oil that you'll see in a transformer. So
Gotcha. And okay, yep, that makes sense. Good deal. Are there any other questions? Anyone, you're welcome to unmute yourself or put a question in the chat. Yeah, I feel like I have a bunch of questions, but I don't want to take over the question asking.
I'm trying to think. I had preloaded some questions. You know, what is the terminology? Just putting that up on the screen. What are those different terms mean?
Yeah.
I feel like I have a fairly decent grasp about cryptocurrencies, but don't ask me to explain blockchains and any particular cryptocurrency in detail. I'm not the person for that. There's plenty of good YouTube videos of what is Bitcoin, so I'll refer you to those references.
I wanted to ask you, Matt, like I feel like maybe we've seen some dips in Bitcoin happen while these folks have been on your system. How do they change anything operationally when the price of Bitcoin goes way, way down?
Yes, they double down and try and move even faster.
They buy the dip, huh?
Yeah, well, I will equate it to a gold mining, like a physical digging gold out of the ground mining operation. They want to extract that resource when the market doesn't have high value for it and hold that resource, because it's generally cheaper for them to mine when the price is low. And then all they have to do is hold on to the resource and watch its value increase over time. So yeah, when Bitcoin was 30,000, most of these guys are actually pretty excited about it. Generally speaking, they're not converting Bitcoin back into US dollars. They have other cash flow, so they are holding on to the Bitcoin asset.
Gotcha. Okay, here's another question from Greg. Matt, do you associate a typical duration for a crypto mining operation? I note above you say they can leave at any time, but I could also see these operations remaining indefinitely, or at least until the mining is no longer profitable.
Right. We haven't. I mean, we've had small mining operations on our system for quite a while, that frankly we haven't known about until recently. The larger operations haven't been on our system all that long. How long do we think they'll be in operation? Some of them, I suspect, are probably in a 3-year window. Others might be here indefinitely. It's a big unknown. So that's really risk mitigation and not treating these customers like you would a large industrial customer that's going to build a building, hire a bunch of employees, and be here for decades. You really have to shift all the risk onto them as the customer and have things paid for up front.
Gotcha.
And any of the good mining companies, I will say, are completely comfortable with that.
Gotcha. Jason asks, is there a price per kWh where mining is not profitable? They're looking for like.
Absolutely.
Gotcha. Yep.
So the answer is yes, but it would be like asking, is there a price per kilowatt hour where mining gold is not profitable? It's like, well, yes, on the near term, but if you see it as a buy and hold asset, you might run at a loss in the near term, planning for appreciation in that asset over time. Although most mining operations do not operate that way. They mine with the intent of being instantly profitable. There are various calculators online that you can type in your utility rate and what you would propose to mine, and they'll tell you, oh, this miner rig will make you this much per day. Right now, mining operations are profitable at Iowa's typical residential rate. So
yeah,
people could hook up a mining rig in their home and likely make it profitable in Iowa. That's why I said in my slides, there's a very high probability you have someone mining Bitcoin in your service territory.
Absolutely. I would just second that. I would almost guarantee there's somebody with a rack and a bunch of graphics cards who's mining Bitcoin. Um, Matt, I'm curious, is there any sort of like unexpected things that happen to CFU or the system, whether it's like an intangible benefit or something you had to work through that you maybe didn't anticipate going into getting these folks on your system?
I would say one of the benefits of thinking about these larger customers is that it has forced us to really understand our cost of service, especially for the larger customers that want very competitive pricing. We really had to dig in and look at every component of our operation and say what are the value components, what are our cost components, and really understand what things were. So we've had a lot of great people at CSU for a really long time, and have had a lot of institutional knowledge programmed into various spreadsheets and things. And so we have spent many months untangling them and really understanding those components and evaluating, okay, this customer is different. Is this cost component applicable to this type of customer? So really understanding that. And then also the value that we represent too. So many hours of long conversations about what are the right numbers and how to go about this. So I would say if there's one intangible component, it's us thinking about that. And then, yeah, just long-term planning. Our peak load is roughly 100 megawatts. What happens if we have 100 or 200 megawatts of Bitcoin miners on our system? Like, what does that mean? How would we do it? That is a absolutely ludicrous question 12 months ago. Now, that was a conversation I had this morning in total seriousness. Oh, you're on mute again, Jeff.
I was just going to say that's pretty wild. You guys are talking about doubling your load. Did I hear that right?
Yeah, maybe tripling it.
Wow. That's interesting.
Right? I mean, that's different than a 1 or 2% increase or decrease or over the course of a decade. The timing, the timing and order of magnitude of things is, it makes it fun, but it really makes you have to pay attention.
Gotcha. I wanted to ask you too, Matt. This is totally out of left field question, but we were at this energy workshop this week that happened in Des Moines, and a gentleman who won an IEDA grant for green hydrogen, in Iowa. He was talking about that sort of thing and how they're also trying to get that curtailed. Sorry, Matt, could you mute yourself? I don't know why, like a lot of sound is coming through. Okay, there we go. Sorry, Matt. Yeah, so we attended this workshop. There's a gentleman there. He's talking about renewable green hydrogen, right? And how they want to set up shop and produce this hydrogen, with curtailed wind energy as well. Do you kind of see them, like the green hydrogen folks and Bitcoin miners, as the same thing, or do you view them as different? Are you even aware of like that IEDA project that's going on with that green hydrogen?
I'm not aware of that specific project. What's interesting about green hydrogen is really the same as battery storage. The idea that we can shift power from when it's being produced to when it's needed. So it's a very interesting concept. And then it just becomes, okay, what is the maybe we don't worry so much about the cost of producing hydrogen, but the question is the cost of storing hydrogen. I know using old natural gas salt caverns has been talked about as an option, but if you have to build structural containment, what do the economics of that look like? It's been a long time since I've looked at that type of thing.
Yeah, it's interesting
Yeah.
to me because I think they're both crypto and hydrogen are kind of like batteries for storing value. But I think crypto may have an end where it's like the curtailed energy is getting used immediately to provide the thing, whereas like maybe there's efficiency losses with hydrogen, right? Because you have to convert it, then store it, then transport it, and then consume it. You know, is that making sense? Like they seem similar as a store of value, but also different.
Yeah, absolutely. The hydrogen is storing that value as a stored energy source, where the interesting thing about the crypto miners, getting a little abstract in this conversation, is the fact that crypto miners are taking power or energy that is not valued because it can't be used and would normally be curtailed, and turning that into a monetary value, a digital asset. So yeah, it's a direct exchange, and then that monetary value can then get turned into any other form of value later on, or in a completely different geography.
Gotcha. Here's another left field question that I have, and sorry I'm asking these questions. I'm really interested in this. I guess like I think the value or the service that these crypto companies, the reason they're making money is because they're assuming a lot of risk. You know, it seems like a lot of the work to make these things happen kind of come from the utilities end. Why are utilities not becoming crypto miners? If you can buy directly on MISO and you have the utility background, why are you guys not buying modular mining rigs? Why would you advise against it if you would advise against it?
I do believe there are some utilities that are doing crypto mining. I don't recall, but I've heard stories of utilities themselves doing crypto mining to use excess production capacity in that way. Why wouldn't CFU do it? That's not our business model. It is fundamentally why we wouldn't do it. We're pretty good at complex financing and whatnot, but we're not spinning up a bank anytime soon. So that is not our mandate as a municipal public power. So we stick with what we're good at and let others do what they're good at.
Makes sense.
And then the capital as well. It is a tremendous amount of capital. The units that the individual mining operations running on our system, they're about $10,000 a piece. So
yep.
To do that at scale is millions and millions and millions of dollars. So that would be our customers taking on that risk, and the reward might justify it, but the risk is over our tolerance.
Gotcha. When you meet with these crypto folks, what's the number one most important thing that they require of you once they're receiving the service of power from the utility? Is it reliability? Is it low or big amounts of curtailed energy that they can use? Is it shutdown hours per year? What do you really care about once they're up and running?
I got to tell you, Jeff, they're pretty easy to deal with from a customer perspective. I mean, it's a giant computer that just runs and solves, does algorithms. So there's not much in terms of interaction once they're up and running. Probably once they're up and running, our typical conversation following that is, okay, now where can we plug in? Where's the next location going to go? So just constantly chasing capacity.
Gotcha. Man, I'm trying to think of if I have another question. Yeah, does anyone else?
I've got some slides that I had. These were just like my reserve, the digital gold rush. Why is there a rush? One is that over 90% of Bitcoin that will ever exist has already been mined. Roughly 21 million Bitcoin will exist, and roughly 90% of that has been mined. The level of difficulty in mining Bitcoin increases over time. So again, very much like gold, where you could just walk next to the river in California and pick up a gold nugget. Those days are gone. Now you need giant mining operations to do it. The same thing is happening in Bitcoin. So that's why there is a rush to get these operations online and mining, is because there's more Bitcoin available and it's easier to get. If they delay and wait, it'll be less Bitcoin is available and it's more difficult to get. So that's why the rush. And kind of the question that was asked by Greg, what do we see the time frame for? I say, once upon a time there was a man that forgot his wallet and was embarrassed because he couldn't pay for supper, so he created the Diners Club. And now I suspect all of us have some sort of credit card in our wallet. So a fundamental change in how we processed an exchange of value transactions. But at the same time, at one point in time, a single tulip was worth more than a house. And then a few months later, it wasn't. Which is cryptocurrency and Bitcoin going to be? Well, based on the time frame, my personal bet is more the Diners Club, a transformation, a next generation way of doing transactions. But I could be wrong, and we might just have a protracted version of Tulip Mania. I really don't know.
Yeah, I think my case for longevity would be seeing new, like, sort of smart contracts come out of like blockchain mining. I think all that stuff's interesting.
Yeah, there are a lot of industries that are adopting the fundamental technology underneath of it. So not tied to any particular coin or company, but the fundamental concept seems here to stay. But not for everyone, at least not Bitcoin specifically. China banned Bitcoin. And again, just to clarify, they banned all cryptocurrencies except their own cryptocurrency. So they have a digital, is it the yen? But they have their own digital currency. So it's not that they're against digital currency, they're just against all others that are not their own. On the other side of things, El Salvador, Bitcoin is legal tender. And bringing it onshore to the continental United States, Intel is officially building ASIC devices for mining companies. So we're manufacturing the hardware in the United States to run this system. Growth-wise, what order of magnitude, how many of these miners are there out there? Grid got in the news because they're on the New York Stock Exchange. Just this year alone, they plan on adding 734 megawatts. So that's in 1 year, and that's just their baby step to get going. So that's their first year as a public company just getting started. They want 3/4 of a gigawatt of power. So big numbers. And then if you watch the Super Bowl, you might have seen a QR code bouncing around the screen for a few seconds. That took you to sign up for Coinbase. It actually crashed their system that it was so popular. So what is the average consumer's sentiment around Bitcoin? There's a lot of people that have been interested for a long time, and there's even more people getting interested in it now. And then I like to do a quick comparison, like again, the gold mine, physical gold mine versus a Bitcoin mine. So the square area of landmass that I'm showing here is roughly proportional, with a gold mine being on the left and a Bitcoin mine being on the right. But the Bitcoin mine is just those small buildings that I have in the orange oval versus the gold mine over on the left. So, from an environmental standpoint, there's, I think, many different lenses to look through on the impact of moving to some sort of digitally secured currency versus a mineral secured currency. And that's all the slides that I have to show.
Here's another question, Matt. If let's say there's a GM on this call who is like, oh, wait, like this can help me grow load. What is their next step? Would you encourage folks to reach out to Bitcoin miners? Do you kind of back and wait? Is there some sort of evaluation that needs to be done to determine whether or not you'd be a good fit? What would you tell that person who would call you up and say, hey, what do I do to get into this?
I would say if you're interested in having conversations with Bitcoin miners and getting them on your system, knowing where you would connect them on your system, like we would connect them to this substation, which has this amount of capacity, and they would physically be located here. Roughly speaking, the cost of getting that system connected would be this. Okay, now you've got your physical, this is where we can plug them in, and this is how much it'll cost. The next step would be, if we're going to do a special rate for these miners, we need to have a really good understanding of what our costs are as a utility. Like you could just give away the energy if you want, but again, I think it makes sense that these large operations benefit your entire customer base. So we've structured our contract rate so that, yes, it benefits the individual company, but it also benefits the entire rate base.
Good answer. Good answer. Does anyone else have any other questions? All right. Any closing comments or Matt?
Well, I hope the information was useful. You guys know where Cedar Falls Utilities is located. We've had lots of conversations with these customers. I would say it really is, there's a few key best practice items, a few upfront things that I would advise you know of. And it really comes down to, these customers want to do big projects really fast. So doing the work up front is not a waste of time because, well, Jeff has kind of gotten to ride sidecar on one of our conversations, and he's seen from, hi, this is so-and-so from this company, I'm doing a brief introduction, to, all right, let's get into a terms of agreement, is like 2 hours flat. So
yeah, I can vouch for that.
it can go really fast.
Yeah, interesting, super interesting. Well, thank you, Matt, for being here. If anybody else has any questions after this, you're welcome to send them to me and I can forward them to Matt. I'll also note that this webinar has been recorded and will be uploaded to our YouTube page. If you were attending today and you want to send this video to, hey, guy in operations, check this out, what do you think? That will be up on our YouTube page here within the next 24 hours. If you just search IAMU, Iowa Association of Municipal Utilities on YouTube, you'll find that. You're also welcome to email me. Again, just want to close by saying thanks, Matt. I really appreciate all this information. And thank you to everyone who attended. And I hope you have a great rest of your day. Thanks.